Now chemical properties. Okay, chemical properties for group 70 is more important than group 1. So especially with iron. Kejap lagi ya. Okay, so now we'll see the reactivity wise. Okay, now group 1, valence electron 1. So group 17, they have 7 valence electrons. When 7 valence electron, untuk mencapai susunan elektron yang stabil, they need one more. So group 17 members akan terima satu elektron. This electron comes from outside of the atom. They pull into the orbital, valence orbital. They need one electron. So who will pull, attract the electron into the valence orbital? The nucleus. The closer the electron, lebih hampir elektron tersebut kepada nucleus atom itu, lebih mudah elektron itu ditarik ke orbital tersebut. So oleh kerana as I go down the group, the atomic size enlarges, membesar. That means the outside electron semakin lama semakin jauh daripada nucleus. Kalau semakin jauh daripada nucleus, difficult to tarik masuk ke orbital paling luar. And difficult to pull into the valence orbital, difficult to form an ion. When difficult to form an ion, bukan tak boleh, boleh. Lebih payah sikit lah, lebih susah sikit. So bila more difficult to form an ion, they don't take part in chemical reaction that easily. In other words, going down the group 17, reactivity decreases. If go up, increases. Fluorine is more reactive than chlorine. Chlorine is more reactive than bromine, and bromine more reactive than iodine. All right. So halogens form an ion by attracting one electron. So they form a 1 minus lah, charge-wise. All right. So going down the group, the reactivity of halogen decreases. Berkurangan. Why berkurangan? I explained to you already. Atomic size increases. The outside electron getting far from the nucleus. Difficult for the nucleus to pull them into the valence orbital. Difficult to form negative ion. So difficult, won't take part in chemical reaction that easily lah. So reason pertama, atomic radius increases. Sebab increases by one orbital one. So ini atomic radius increases. Next, outside electrons getting further away from the nucleus. So elektron di luar semakin jauh daripada nucleus. Maka daya tarikan mereka ke orbital paling luar sukar sedikit. So sukar untuk membentuk charge negatif ini, 1 minus, N ion ini. So jadi kalau sukar membentuk N ion bercharge 1 minus, then sukar untuk mengambil bahagian in chemical reaction. So some chemical reaction. First with water. What will happen if halogen you place in water? So 3 halogen. Kalau group 1, lithium, sodium, potassium. 3 elemen kita belajar. Untuk group 17, also 3. And these 3 will be chlorine, bromine, and iodine side. So we know chlorine, gas state. Bromine, liquid state. Pada suhu bilik. Iodine, solid state. So jadi bila mereka hadir dalam 3 fasa yang berbeza, 3 different phases, then for us to react them with the water also involving 3 different methods as well. We cannot use the same method. Because 3, gas, cair, pepejal, 3 jenis. So kita lihat yang pertama dulu, kalau chlorine. How the experiment will be done? This diagram is important. Why important? Normally, they akan tanya, how to produce or prepare chlorine gas. You can produce chlorine gas by reaction between concentrated hydrochloric acid dengan potassium manganate 7. Alright, when you put potassium manganate 7 into hydrochloric acid, concentrated hydrochloric acid, they will liberate, akan membebaskan gas chlorine. Gas chlorine itu will bubble out in a distilled water. That means distilled water ada air. So kita gelembungkan di dalam distilled water, air suling. That means they are reacting. Ini kalau gas. So apakah bahan kimia yang digunakan untuk menghasilkan gas chlorine? penting. Okay, ini sebab gas. Yang kedua ialah bromine. Bromine is liquid. So liquid means easy. You take a few drops of bromine liquid, drop it into distilled water. Let them react. Then we test. Kalau air ini merupakan pepejal. Kalau pepejal, don't drop air into water. Get a beaker, letakkan air di dalam, test tube pun boleh. Letakkan air di dalam, then you pour water. Can. Then they'll react. Much more easier lah. Okay, cara dia. So, 3 apparatus yang berbeza kerana 3 fasa yang berbeza. Slightly the changes, they're getting darker and darker. But with what we call litmus paper, we want to see whether they are forming alkaline solution or neutral solution or acidic solution. Bila kita ambil unsur kumpulan 17 ini masuk ke larutkan dalam air ini, kita dapati bahawa kertas litmus biru turn to red, after that bleached, dilunturkan. So important blue litmus paper turn red and then bleach, dilunturkan. Menunjukkan dia beracid. Beracid into red tadi. Blue litmus paper turn red, menunjukkan dia beracid. Bleach bermaksud dia bertindak sebagai peluntur, melunturkan. Okay, later we'll see the application lah. Okay, chemical equation. So when they react with water, they form HX plus HOX. Okay, this equation is important, especially for chlorine, especially their name. Namanya penting. Alright, so X2X mewakili halogen, like a Cl2, Br2, I2. Bila larut ke dalam air, dapat 2 produk, HX and HOX. Okay, write down all the equation first. Write down all the 3 equations. The next challenging. See who can give you the answer. I want the name of this compound. I only want the second one. I'm interested in the second one. First one, very common, hydrochloric acid. The second one ialah hypochlorous acid. Bahasa acid hypochlorous. Okay, ejaan ejakan nantilah. Tapi acid hypochlorous. Yang kedua, hypobromous. Yang ketiga, hypoiodous acid. So yang chlorine, the first equation, they will ask in exam. Dia pernah tanya dalam soalan. Okay, apakah nama HOCl? So hypochlorous namanya. Alright. Let's go.